Hi, this is Tony Reynolds, and we're going to be working in ZBrush and creating a BPR render that will then composite the different layers in Photoshop. So here we have the demo model from my portrait production video, and I've used the demo SSS soldier material that you can load up and modify it a little bit. I've also adjusted some of my SSS BPR settings. First of all, let's cover some of the render settings. So if you look over here, I have SSS turned on and BPR SSS here. You always want to have calculate SSS across subtools on because otherwise you tend to get artifacts, so that's best. I've increased the raise to 64, left the angle at 360. This angle, basically by lowering it below 360, will make the fall off of the subsurface scattering broader. So I cranked it up because I wanted a little bit tighter. I've increased the resolution for the subsurface scattering to 1024. By raising this, whenever you change the minimum opacity in the actual shader, it'll give you better results and you'll have less artifacts. So I always increase it. It increases the render time as well, but the render time on this is quite short, so it shouldn't be too big of a deal. The blur I set to 8, and that's just a pixel radius blur. It seems to work pretty well for the resolution that I'm working in here. V depth is the view depth offset in pixels, and what this does is if you set a negative value, it scatters light towards the view, and a positive value scatters it away. So I left it at 0 because I don't want to change the offset. The subsurface scattering light depth offset I've changed to -20 because I want the light to actually scatter towards the light. It's basically the same thing as the V depth, as in a negative number goes towards the light and a positive number goes through. If you watch my other video, you know that the skin basically reflects more light than it actually absorbs and passes through the other side, so this helps us get a little closer to that. I've turned on subpixel depth calculations just for more accurate subsurface scattering. You'll find in ZBrush that the subsurface scattering really isn't physically accurate, but if you render out everything separately, you can actually composite in Photoshop fairly well and get pretty decent results. I've set the softness to 2.5. It's a good round number to work initially to get some detail, but not too much. If you set the softness to 0, you'll get very detailed looking subsurface scattering, and it isn't quite soft enough, so I crank it up to 2.5 for a general render to get an idea of where I'm at, and then I start, when I actually start isolating different parts of the SSS, I will change it based on whether I'm rendering the inner or outer blending. Subsurface scattering softness radius in pixels, set it to 4. If you cranked it up too high, you would lose a lot of detail. And as you can see, this model is quite detailed, so I'd like to get some of that wrinkle information in there. And I've set the subsurface scattering softness fall off to 2. Now, if you actually look in the material, this is where all the magic happens. So right now, my shader is set up into 3 different layers. There's S1, which is mostly the diffuse and specular contribution. S2 is the actual SSS contribution, and shader 3 is another specular contribution, which is more of an anisotropic spec. So when you're testing, the best thing to do is actually turn off the contributions of the diffuse on any spec, because you just want to see, we actually just want to look at the SSS contribution. So I'm going to turn the specularity to 0, and 0 on the S1. I'm also going to turn off diffuse, and turn the ambient off as well. So basically we have a black looking head, and under here I've saved a view, so I'm going to go to that view. And when you save a view under your document in ZapLink properties, for one, you have to have ZapLink loaded, and the nice thing about that is I store the front view, and I can always go back to that and then re-render and use that for compositing. That way I'm sure that I'm always at the same angle. So if you notice too, as you click through these modifiers, S1, S2, and S3, they all have their own, under the shader mixer, they all have their own SSS information. For S1 and S3, set the SSS to 0, because we don't want this to actually calculate any SSS. So under SS2, I've set the value to 100. You could turn front subsurface scattering on. I haven't seen that it's made a difference whether it's on or off, so I'm leaving it off. The fall off exponent I'm setting to 1.25. Now here's something. I make sure on black is on, and basically what this does is it starts the shader with a black value and then creates the SSS on top of that. If you turn that off, you'll get a lot stronger effect, and I really don't want a very strong effect. Also, my blend mode I set to linear dodge, which is basically an add. And I left my min opacity and max opacity at 0 and 100 respectively. That way, I will have pure black in the render and a full-on 100% contribution of the SSS. Preview opacity, you can mess with that. It doesn't. You would have to actually do a render first and then adjust this preview opacity until it looks like something close to what you've rendered. So I don't really care about this because we're just going to do a BPR render anyway. So under the actual modifiers, the inner additive, I try to set to 0.05, and ZBrush tends to change that a little bit, so it's not always accurate. The outer additive, I set to the same value. I set the inner blend value to half of the outer blend value. Just seems to give me better results. And my Fresnel factor, I set to 1.5. At 0, it'll be a very soft overall blend between the two. 1.5 gives you a little bit tighter fall off on the outer blend, and the inner blend ends up being a little broader. The other thing that I've changed here is my colors. So for the inner additive color and the inner blend color, I'm changing it to a yellowish, kind of yellowish brown color, and it's darker for the additive value and brighter for the blend value. I've left the outer on the default colors, which is basically a pink and a red. So let's go ahead and do a quick BPR render. By the way, under my render settings, I'm just turning SSS on. I've turned off shadows and everything else. I don't want to see any shadow contribution in this. And I also want to create my maps so I can store those images and save them off for later. You can change the subpixel anti-aliasing render quality up, but 0 seems to be fine for what I'm doing. And let's go ahead and render that. Okay, so it just created the BPR render. And up here under my render menu, you can see that I've created the image for the BPR. If I want to save that, I can just click this and save it where I'd like. And we'll do BPR SSS base. I'm going to save the depth because I like to use that for my lens blur when I go into Photoshop. And I'm saving a mask off. So, as you can see, the inner is the yellow SSS and the outer part is the red. The thing is about this that I would like to be able to control the effects of both of these independently. So what I'm actually going to do is change my values on my inner blend to basically turn them off, render just the outer blend by itself, and then turn off the outer blend and turn on the inner blend and render those out as two separate passes, and then in Photoshop we'll composite that. But these effects look pretty good. We'll be able to actually work pretty well with this in Photoshop. So let's go ahead and turn off the inner additive value, set it to 0, and the inner blend, set that to 0 as well. And when we render, we should just get the outer blend effect of the SSS. Because of the limitations of ZBrush and how it calculates SSS, this is probably the best way to do it so that you have full control. And rather than sitting here and rendering a million times, tweaking all these settings, it's never going to be quite right. So when I do this, what's going to happen is I'm going to get the red outer blend pretty much everywhere. And this is very similar to what's called the backscatter in mental ray render. So I'm going to render this, and then in Photoshop, I'm going to mask out the areas that I don't want it to show up on, like the top of the skull, inside the jowl area and everything. I'm pretty much going to keep it to the ears because that's what would actually show up in a backscatter render in mental ray. So that's the render. And as you can see, it's very subtle on the ear, but it'll work out well. And you see how strong it is along the skull? That's completely unnatural and wouldn't really happen in the real world. So that's the beauty of having this separately. We'll be able to go ahead and fix that in Photoshop. So let's save that image. And we'll call this outer SSS. And now we'll go ahead and set these settings back for the inner and turn them off for the outer. And then we'll re-render. So here the inner blend has rendered, and we'll go ahead and save out that render. And one thing I forgot to talk about was under the lights, if you open up that SSS Soldier project, you'll have the lights already set up, but you need to have one light set to SSS, and that light shouldn't be on. The lights that should be on are the ones that have shadows, and they should not have SSS on. By turning it on a hidden light, it enables the actual render to calculate the SSS. Without that, it doesn't work properly. So just be sure to do that, or be sure to have some light with SSS on. Okay, so now we've rendered the outer and inner blend, and now we're going to start rendering everything else. So I'm now going to turn off the SSS completely. You can do this alternatively by going up to the SSS contribution here and turning that to 0. Changing all these additive values and blend values to 0 will do the same thing. So now that I've rendered out the sections of the SSS that I need, I'm going to go ahead and render out the diffuse. And the way I'm going to render out the diffuse is by re-enabling my ambient, which was 22, and my diffuse set to 40, and that was in my S1 component of the skin shader. So the other thing I'm going to do as well is turn off the BPR SSS, turn on shadows, turn on ambient occlusion. And what this will do is it'll render the diffuse, it'll render a shadow map separately, and an ambient occlusion map as well. We can mess with some of these settings. The higher the ray count, the more accurate it's going to be. Let's up the resolution so we can get all these little wrinkles in here. So 400 is not big enough. I'm going to set that to 1024. I'm going to increase the rays to 32. And then under the shadow, let's increase the rays to 16. Resolution at 1024 should be fine. And let's go ahead and render that out. Okay, so the render finished. Doesn't look gorgeous, but it's good enough. And we'll be able to use this to get some of the color detail into the final composited image. So let's go ahead and save this. Let's call this diffuse. Save out the shadow. Save out the AO. And before we move on, we're going to go ahead and render a flat color render. Has no shadows, no nothing. So to do that, we're going to turn the ambient up to 100. Turn diffuse off. And I'm going to have to do that on all my materials. So set that to 100, diffuse off. Turn off the spec on that. So this should get us a good render. We're going to take shadows, turn them off. We don't need ambient occlusion anymore. And let's just do a quick BPR render of this. It should take no time. And did it. So now I'm going to save this as ambient color. And when we get into Photoshop, you'll see how I'll composite this stuff together. So now let's switch everything back to the way it was. So now we need to render specularity. So on every shader, we're going to turn on the spec and turn everything else off. So we're going to set the ambient to 0 for the eyes. We're going to increase the specularity to 32. For that, we're going to go into this shader. We're going to set the specularity on this to 12. Turn off the ambient completely. Turn the specular on here to 8. Turn the ambient here. And specular at 4 should be good. Now let's try a little bit lower too. Alright, so now when I do this render, I'm just going to get specularity. And let's see what that looks like. And that took no time, so it rendered out the spec. So now I've got an inner and outer SSS render. I've got a shadow render. I've got ambient occlusion. I've got an ambient color. I've got a spec. And I have a straight up diffuse. So I think we've got all the renders we need to composite and make a decent image out of this. So we're going to go ahead and open up Photoshop and see what we can do with these renders. So here we are in Photoshop, and we've got the final composited image. Looks pretty good. Looks like a semi-decent skin result. And I'm just going to run you through how I took all the layers and composited them together. So first things first, under the channels, you can see I've added the depth render to the first alpha channel. I've added ambient occlusion to the second alpha channel. And the third one is just a straight up mask to be able to mask out the background from the foreground. The reason I put the AO in the second alpha channel is because it's not actually going to be just overlaid on top of the render. What it's going to be doing is actually masking out our ambient color render that will then add color back into the base render. So I'll show you how that's set up. So let's show basics, and we'll go through and build you up. So here's the base diffuse render. It doesn't look so good, but the first thing I did was I added the ambient layer as a screen and applied the ambient occlusion as a mask on this. So essentially, it's only adding in ambient in areas where the ambient occlusion was purely white. I also masked out the shirt here. So then the next layer on top of that was the shadow. I set that to multiply. It's a very subtle change, but it's bringing back the darks in there. And then I created an adjustment layer that compressed the white to black range and increased the effect. It's a little harsh, but we'll get rid of the harshness with some of the other layers. So the next layer I added was the inner SSS. And as you can see, it's adding color to the nose and the chin and in general over the whole head. The layer is set to linear dodge, and I also made sure to mask out the shirt area so I wasn't adding any color to that. The next layer I added, another linear dodge, was the outer SSS. And for that I masked it and filled the mask with black and only painted back in the ear area and maybe some areas along the shoulder just to add a little bit of color there. Because if I had have used the whole thing, it would have had a red halo all the way around, which kind of doesn't look very good. So then the next thing I did was I added a blurred version of the shadow layer on top, again as a multiply. And I created a copy of the ambient and set it at color burn, and then painted in areas only where the core shadow should be. So it's basically increasing the color saturation in those areas. Next, I added the spec and applied a mask to it and painted in the areas where I wanted the specular to be stronger and painted out the areas that I didn't want it to be stronger. And I did a hue shift on it to try to change it a little bit and not make it just pure white. And then on top of that, I did another linear dodge and blurred the spec to kind of give it a little bit of bloom. And then I added another one that actually has a compressed value range by applying adjustment layer. That was a levels adjustment layer. From there, I had flattened everything and used my mask here to separate the foreground from the background. And then behind it, I put a gradient that was overlaid as a multiply. Then I created another adjustment layer, and that's a photo filter layer. I set it to cooling and the density to 15%. And then the final thing I did was I created a flattened layer and applied the lens blur filter. And the lens blur filter used the depth mask that we had generated, and it basically gives the illusion of some kind of camera depth. So that's the anatomy of this composited image. It's not perfect by any means, but it was just to demonstrate how you could actually generate BPR renders and composite them in Photoshop taken more time. I could make a better image, change my lighting, it would be more dramatic, but I just wanted to show you how you can get a skin-like quality by rendering BPR renders out of ZBrush and compositing them in Photoshop. I hope you've learned a bit, and I hope you've had fun. Good luck.